through this class right now. So if you missed yesterday, third hour, we just sent the people out in the hallway to watch the video from yesterday. Because honestly, like, so people that were here, do you think they'll be able to understand today's stuff if they weren't here yesterday? I don't think you will. So you do what you want. If you want to stay here, that's fine. If you want to watch the video that I posted yesterday, that would be my recommendation. But at the end of the day, you do you. It's America.
Bye.
Later, Gator. Oh, we're done. Wait, we're done.
Yeah, no, we're done in the video. I think it's easy.
On your mark, get set, go. Ready? Take the earrings today. I didn't wear mine.
Should have worn this.
You should get your
Dave,
just one.
Just one?
And you should get one and then square
What?
like a dangly diamond.
A dangly diamond.
Yeah.
Okay.
I was like,
What's
But it's gotta be like art.
Okay. All right. I'll do it when we get to cut Tony's hair. Floppy mop, dude. Floppy mop. Time to cut it off. Give Kaden a hint as well. All right. So yesterday we saw kind of the most basic examples of simplifying trig expressions. They do get more difficult. Caution, some people actually found themselves starting to enjoy this during second and third hour. They didn't want to admit it, but if you haven't figured it out yet, if you're taking college algebra and college trig and getting 7 math credits while you're in high school, and then some of you taking calc next year for another 5, you're kind of a little bit of a math geek, okay? All right, so embrace it or deny it, okay? I offended her, she's leaving. Okay, all right, sorry about that. So let's try problems that are slightly more difficult. I can't always tell you what to do when. You have to be able to recognize and apply. So this first problem is tangent squared divided by secant minus 1. When people see this, they often think, oh, secant minus 1. I'm going to substitute something. And so they go to their bag of tricks and grab a formula, and they're like, secant minus 1, let's see. Oh, yeah, look at that. Secant squared minus 1 is tangent squared. So you tell me, if tangent squared of x is equal to secant squared of x minus 1, then is tangent of x then equal to secant of x minus 1? Can I just take square root and square root of that? I take square root of each of those. Boom.
no.
Yeah, it's completely illegal. And not necessarily because of the negative, but if you just think about this, is 9 equal to 25 minus 16? Yeah, let's take the square root. And then you try this voodoo thing where you go, okay, well, that's 3, but then you just do 5 minus 4. Is that the same? Absolutely not. This is not a step of equality. You can't do that. So we can't just put in tangent on the bottom. So I'm going to do something else. Notice on the problem that I'm looking at, in the top, you have tangent squared. And I'm going to substitute that in its place. So it looks a little bit ugly at first, but we're going to make it really pretty in the end. Hey, come on. There you go. Okay. So on the top, instead of tangent squared, I'm going to write secant squared of theta minus 1. And in the bottom, I'll write secant of theta minus 1. Now you need to see something special about the top. They don't cancel. It can be factored because it is the difference of 2 squares. Aaron sees it. This is what you have to be able to see. It factors as the difference of squares. Secant of theta minus 1 times secant of theta plus 1 over secant of theta minus 1. Sometimes people ask me, well, Mr. Gans, what if the test comes and I can't see it? Easy. If you can't see it on the test, then you get it wrong. So you have to just be able to see it. I'm sorry, I wish it was different than that, but that's the deal. Those cancel, leaving you secant of theta minus 1. Plus, just checking to see if you guys are awake. Wake up, ZZ. Stop sleeping. Stop sleeping in my class.
I actually caught that.
Way to go. All right, sine squared. You are going to substitute something in for sine squared, and the problem is going to work out in a very similar fashion to what happened with this one. Try it on your own. Go. See what you can do. I try, you try. I try, you try. Yeah. Yep, 1 minus cosine squared. Very good. Yep, 1 minus cosine squared. I'll just put an A plus on the top. How's that? Yep. Okay, as you can see on the top, I have cosine of theta plus 1. On the bottom, I substituted 1 minus cosine squared. And 1 minus cosine squared is the difference of two squares. So they factor. And now I can cross off cosine of theta plus 1. So your answer is 1 over 1 minus cosine of theta. Notice that when we see a squared, that's to our advantage. If we don't see a squared, sometimes if we could create one, that's a good option. What could we do to create a squared for letter C? Distribute. Notice you get secant squared. And then secant times cosine. What is the relationship between secant and cosine? They are reciprocals. And when you multiply two reciprocals, you get 1. Secant squared minus 1. That looks familiar. Tangent squared, so says Mia. What's Mia's middle name? What's your middle name? Lynn. All right, Mia Lynn. I like it. We could give you a middle name too today if you wanted to, if you didn't have one. Jordan got Anastasia. Next one, I distribute sine through, and I get sine squared. And notice sine times cosecant gives you 1. Times cosine squared. So I've got cosine squared. And this is that point. This is that point. Look at, don't say it, don't say it, don't say it. Everybody just look at it for 10 seconds. 10 seconds. Don't say anything. See if you can figure this out. And time's up. What is it? It is 1. Sine squared plus cosine squared is 1. Sine squared plus cosine squared is 1. Sine squared plus cosine squared is 1. It is the most important, most fundamental formula in all of trigonometry. What's that? About that. No, don't put words in my mouth. Don't put words in my mouth. Yeah.
So why do we not get assigned over? This should be assigned over to cosine squared.
Good point. So let's change the problem. So every time you're wondering about what you're allowed to do from an algebraic standpoint, realize that you can model this in a different way. Suppose that looked like this. X times x plus yz squared. I mean, that's kind of the same thing you're looking at there, right?
Yeah.
So if you multiply this, you get x squared plus xyz squared, right? It's not like the x times the y and the x times the z squared, right? Nope, doesn't work like that. All right, we flip it over. Again, it's great to create a squared. If you notice, these two are what we call conjugates. And a conjugate is when the signs are different on the end. So when we multiply this out, do you remember what happened when we multiplied two conjugates? the middle cancels. So you get 1 times 1 is 1. 1 times cosine is cosine. Negative cosine times 1 is negative cosine. And negative cosine times cosine is negative cosine squared. And so we said because they are conjugates, what's going to happen? The middles will cancel. And did the middles cancel? Yes, they did. And so the middles are gone, and I get 1 minus cosine squared, which is sine squared of theta. Again, if you can remember that as opposed to looking back at your sheet all the time, that would be to your benefit, okay? Letter F, are those conjugates? So therefore, the middle will cancel. Tangent squared of theta minus secant squared of theta. So you see the tangent squared, the secant squared, it's like the thing that's missing is 1. So it's kind of what you want to go with, right? And you're very close. It is negative 1, but why?
So on here we have 1 equals secant squared minus sine squared. So we can flip it to it now.
Right. Let's look at it 2 ways to see why it's negative 1. And by the way, this is problem number 5 from your worksheet from yesterday. So if you look at it, I'm going to start with our known identity, which is 1 plus tangent squared of theta is equal to secant squared of theta. Everybody agree that that's a formula that we have. I'm going to make this formula look like that. I'm going to subtract the secant squared over. So 1 plus tangent squared of theta minus secant squared of theta is equal to 0. Now, in order to make it look like that, I just have to subtract the 1. As you subtract the 1, does everybody see it becomes negative 1 on the other side? So that's a good way to show that this is, in fact, negative 1. Some people don't like that route, and so they want to choose a different option. Can I show you another way? Secant squared of theta is the same as 1 plus tangent squared. And we get tangent squared of theta minus 1 minus tangent squared of theta. Notice how the tangent squareds cancel, and I get a negative 1. So either way you go about it, you're going to come up with negative 1. Multiple ways of doing the problem, which makes it exciting. You try letter G on your own. Go. Secant. You got it. Everybody start with that? Recognize you can factor out the 4? And secant squared minus 1 is tangent squared. So you get 4 times tangent squared of theta. Pretty cool. All right, we try a couple more. We're going to do 5 more problems here, and we'll give you guys some time to work. Tomorrow, you do not have an assignment, or you do not have a lesson. Tomorrow, you have all day to work on these type of problems, which means you can move on to the next assignment. It is imperative that you practice these problems. All these problems, you can simply just take a picture of them and try them on PhotoMath, and it'll show you how to do all the problems. And if you do that, you can expect to get about 8 out of 42 on your next test. So I would not do that. PhotoMath is the devil, okay? So don't use it. All right. All right. The next one, letter H. We graduate to level 3 type problems. Level 3, okay? So we've kind of seen a lot of level 1 and level 2 type problems. But now let's look at something that's a little bit more challenging. Yeah. I would say we'll go to 4. We could show you a 5th level, but we just don't have time for that. So we will stop at kind of level 4. But yeah, Yeah, letter H looks tough. You may see to factor out a cosine, but if I factor out a cosine, I'll just be left with tangent plus cotangent. And that's not anything special, is it? So when in doubt, sometimes you might choose to rewrite it in terms of sine and cosine. And one thing I see when I do this is that I don't have a squared right now, do I? But if I change it in terms of sine and cosine, I can see I'm going to get a squared. Do you see where you're going to get a squared? Right there, aren't you? Watch it work out. Cosine of theta over 1 times sine of theta over cosine of theta. Plus cosine of theta over sine of theta times cosine of theta over 1. What happens on the left side? Cosines cancel, which is very nice. So I get sine of theta over 1 plus, and then notice here, this is where I come up with that cosine squared. We like getting cosine squareds or sine squareds or anything like that, because when we get squared, you can always substitute something in. But now as we look at the next step, you may say, well, what pairs well with a cosine squared? What do we like to see with a cosine squared? A sine squared. Is there a way we could get a sine squared? Create common denominators. Top and bottom by sine. And on the top, we get sine squared of theta plus cosine squared of theta all over sine of theta. And now here's where I can't help you. You have to see it. One. Sine squared plus cosine squared is 1. Yeah? And what's 1 over sine? Cosecant. Nice. You want to try letter I. It's going to work out very similar to what you just saw for problem H. Okay? Try the same type of approach. I bet you come up with the right answer. Okay? I try, you try. Great educational technique. See what you come up with. You can do it. I believe in you. You're super smart. You're the best of the best. The hope of all humanity moving forward. There you go. Nice job. Okay, did everybody at least rewrite it like this? Here's the mistake that people make. They sometimes cross off the cosines. Can I do that? Totally illegal. Yep, you got that addition sign there. Can't do that at all. So what you have to do is you got sine squared of theta over cosine of theta plus cosine of theta over 1. Now, I'm going to multiply the top and bottom here by cosine. And notice when I do that, I create a cosine squared, don't I? Sine squared of theta plus cosine squared of theta all over cosine of theta. And again, sine squared plus cosine squared is 1. 1 over cosine of theta is secant of theta. Isn't it amazing when you do this stuff though, like you kind of find yourself making up mathematics? It's like you break the rules every once in a while, don't you? You know what I mean? No, like for example, like, you know, x plus y over x. You know the temptation is to do that, right? But you can't. Just like say 42 divided by 2, you can't say, well, that's 4, right? You know what I mean? But it gets kind of funny when you get in the letters. You get kind of confused, don't you? Like, say you did sine of x and you divide it by n. You're like, okay, well, I get 6 out of that. You know what I mean? Like, all of sort, you know what I mean? Like, it's crazy the things we could come up with. So, Zizi? You had a question, I thought. No, yeah. Oh, yeah, yep. So generally speaking, so good idea, like how I would grade this one. So let's say that this would be a 3-point problem. I'll give the first point for rewriting it in terms of sine and cosine. And I'll give a second point if you can come up with a sine squared and cosine squared. And then the third point would be able to get to the secant. So, you know, if you multiply by the common denominators and then mess up from there, maybe I'll give you 1.5 points. But I do look for certain stages. So that's kind of how I set it up. And when I look at your work, and it like if I see the wrong answer, so if I see the right answer, then I look back quickly to make sure that you progressed it right. If I see the wrong answer, then I start the beginning, and I'm like, okay, where did they go awry? And that's kind of thought. But I try to find ways to say, oh, that looks like reasonable mathematical work. Honestly, sometimes it's just, you know, half of it ends up being just like Hogwarts magic, if you know what I mean. Yeah. Yeah.
Okay, so sine squared of theta plus cosine squared of theta over cosine.
Yeah.
How did you get that?
Because it falls.
Sine squared plus cosine squared is? Sine squared plus cosine squared is 1. All the time. You try letter J on your own. J. As you see here, you can cancel these cosines because they're all written as multiplication. So therefore, you get 1 minus sine squared of theta. And what is 1 minus sine squared? Cosine squared of theta.
I thought it was connected, my bad.
That's all right. So our last two problems, we are going to get rid of this one, and in its place, we are going to put secant of theta minus cosine of theta divided by secant of theta. So now we get to kind of a level 4 type problem. Okay, people will get a little bit confused. They don't know what they're doing. Or figure it out. There's 2 ways to do this problem. I'll show you both ways. The first way to do it is to rewrite in terms of sine and cosine. So 1 over cosine of theta minus cosine of theta over 1 all over 1 over cosine of theta. That looks kind of ugly, doesn't it? After all, that has now become a complex fraction. Now, here's the interesting part. You have taken your last algebra course. You took that first semester. You are now experts in algebra. Do you feel that way? That means that every single algebraic expression you see should be a piece of cake. Fact is that we need continued practice, don't we? So when we deal with complex fractions, do you remember how you deal with those? Eventually, we'll multiply by the reciprocal, but first we need to
get the top one down.
top one down to 1 fraction. So we're going to have to find common denominators. Now, as we just try to glance ahead, when we find common denominators, what is that going to create for us? a cosine squared. So already I like this option because I see I'm creating a cosine squared. So what do you have in the top? And in the bottom you have cosine, and then 1 over cosine. Now you can multiply by the reciprocal. And what happens? I'll show you a second way to do it, but first I need to share with you, I had a few kids that were in the younger grades. They were in 8th grade, and they were doing some math with their teacher today, and they were having to do like x over x plus 2 plus 3 over x minus 1. They had to add those together by finding common denominators, and the quote was, I was so ready to cry in class because it was so difficult. You know what I mean? And I think that we look at it and we realize if they can't get themselves to do that, are they going to be able to handle doing that? Well, heck no, right? Like that seems like child's play now to you guys, doesn't it? Okay, so it's good to pause every once in a while and just remember that when you were younger, maybe you thought that something that was challenging. You've really learned a lot of math over the years. You really have, which is impressive. I want to show you a different way of doing the problem because that's the way I would have always gone to the problem when I was starting it. But some people like this other option better. And the other option I'm going to use just a little bit of logic here. Do you guys agree that if I have 2 plus 4 over 7, would you guys agree that that's the same as 2 sevenths plus 4 sevenths? So you can take a fraction like that and pull it into 2 fractions, can't you? So I'm going to pull this into 2 fractions. Secant of theta over secant of theta minus cosine of theta over secant of theta. So what's really nice about that is that secant over secant is 1 minus, and then if we divide by secant, that's the same as divide by 1 over cosine. Instead of divided by 1 over cosine, we multiply by cosine over 1, and so you get cosine squared. See that? Either way works. Whether or not you see which way really depends. I use that strategy a lot in calculus when I'm doing work. A lot of kids, I'll admit, they don't really like that way, but I find it to be very, very useful. Last example. Let's say if you do a problem like this, you're doing really well. I've been doing all the work. You've been helping me out. How about you help me out now? Where do I start? Okay. I will grant Kenny's wishes. We will turn it into cosine of x over sine of x. Why? So this is interesting. I want you to think about the line of reasoning here. We could create common denominators because we're adding fractions. Let's have a different reason for doing it. What will finding common denominators create for us? Squares. Do you see that? That's the goal, is that we create the squares. That's why we find the common denominators. I have sine of x over sine of x. And I have 1 plus cosine of x over 1 plus cosine of x. What do you get on the left-hand side? Sine squared of x plus, and then what does the right side become? Cosine of x plus cosine squared of x. Over sine of x times 1 plus cosine of x. I tend to not distribute the denominator. I tend to only distribute the numerator. Looks like a bunch of hogwash right now. Yeah, sine squared plus cosine squared is 1. 1 plus cosine of x over sine of x times 1 plus cosine of x. Yes, and Aaron sees that the 1 plus cosine of x's, they do cancel, leaving you with 1 over sine, which is cosecant of x in all of its beauty. Sometimes I like a problem so much I just put a smiley face at the end of it. All the things you could do to communicate with me on your test, your joy of mathematics. You can even, like if you really like the problem, you can do like a heart. I guess if you really hate it, you could break the heart. Shoot a couple arrows through it. All sorts of options. All right, good job. That's really the instruction. I've tried to show you a wealth of problems, okay? A wealth of problems to prepare you. You are now ready to complete all of your first assignment. It would be completely abnormal if all of you were able to do these problems and not have to ask any questions. In fact, I would say that I don't anticipate anybody going through here and not having to ask a question. They're tough problems. You're ready also to move on to your second assignment. And you get all day tomorrow to work on that next assignment. I would encourage you to try to do as many of the problems you can before you get to class tomorrow so that you can ask questions on the problems you are struggling with. Some problems are easy, some problems are tough. Don't feel bad if you run into a tough one.
So do you want to solve our way back to the side?
Yep.
Okay.
Or go up and
You can now do everything up until where it says 7.2. That will be Thursday. And by the way, for the rest of the unit, I can always tell you what to do when. For this first one, you kind of got to guess and navigate. After this, I give you formulas that you use distinctly the same way every time. And we will miss you. Tell you what, since you're going to be gone, I'll record the video and I'll post it for you so that way you can catch up on your work when you're gone.
Thank you.